create and analyze models. It's the second process of the analysis knowledge area, and it's part of the executing process group. It's one of the largest processes the business analyst need to conduct or perform as part of his or her efforts as the BA for the project. And for the PMI PBA exam, it's one of the most important processes. There are more than 25 questions in the business analysis professional exam about the different types of models I am going to cover as part of this lecture. So it will be a very long lecture, but it's very important for the exam preparation purposes. So create and analyze models is the process of creating structured representations such as diagrams, tables, or structured text of any product information in order to facilitate further analysis by identifying gaps in information or uncovering extraneous information. So representations, diagrams, tables, or structured text are all examples of the models you are going to create as part of this process. Now, the key benefit of this process is that it helps convey information in an organized manner that provides clarity and helps achieve correctness and completeness. People or stakeholders always prefer to see the information organized in diagrams or tables. They prefer to see information in this format instead of seeing only text. Now, the create and analyze model is part of the analysis knowledge area and the executing process group, and the inputs, tools, and techniques and outputs for this process are shown in the figure below. So I am going to walk you through 3 inputs for this process, around 19 tools and techniques, and only 1 output, which is the models you are going to create in this process. So as you can see from this data flow diagram, which is one of the data models we are going to explain in this lecture, create and analyze models will have inputs from the confirm elicitation results process, determine analysis approach, and define and elaborate requirements. And the outputs of this process will be very useful while you are defining and elaborating the product requirements and when defining the acceptance criteria. Now, what's the definition of models? Models are visual representations of information. So models are always visual. It is something you or the stakeholder need to look at. So it's a visual representation of information in the form of diagrams, tables, or structured text that effectively arrange and convey a lot of information in a concise manner. So this is the simplest definition of the models, and this process includes both developing the analysis models determined by the analysis approach and using those models to improve the overall product information. So from this paragraph, you can understand that the types of models you are willing to create should be defined as part of the analysis approach. Analyzing models is helpful for finding and identifying gaps in information and identifying extraneous information by exploring the solution from multiple perspectives. Models provide context to discussions and analysis and provide for better understanding of complex relationships and concepts between different parts of information. Models can convey information more clearly than textual descriptions, and that's normal. Models provide a concise format to present information and can be used to clarify and discover information with the different stakeholders in the project. Analyzing models involves looking at few pieces of information, not necessarily the whole set of information, and finding the patterns to explore the problem space further. All these are benefits of creating analysis models in your project. Drafts of models are created based on the confirmed elicitation results. This is why one of the most important inputs to this process is the elicitation results. Those models might go back through the elicitation sessions in order to identify new information to be refined and reanalyzed in the models. The create and analyze models process is often performed concurrently with the determination of the analysis approach and confirming elicitation results processes. Now, models are important inputs to business analysis activities that occur outside of the create and analyze models process, including, first of all, defining and elaborating requirements. So the models you are going to create in this process will be the key input for the process of defining and elaborating the requirements. Then building a shared understanding of the information across the project team and the stakeholders. Mapping the relationships and dependencies within the and across the portfolios, programs, and projects of the organization. Finding information gaps which will require additional elicitation. This is why sometimes the outputs of this process will go back to confirm elicitation analysis process. Identifying stakeholders who were not previously identified or included. Facilitating stakeholder understanding of the information. When I say information, I mean the product information during elicitation or review. Assessing capability gaps between the current and future states of the product. Analyzing changes to identify which areas of a product are impacted. Understanding what is of value for users. Prioritizing product information or projects in portfolio, and providing a business perspective on architectural designs. All these are benefits of creating and analyzing models outside of this process itself. Now, when we say models, there are 5 categories of those models, starting with the biggest category, which is the scope models, bounding the solution. Models that structure and organize the features, functions, and boundaries of the business domain under analysis. This is the definition of the scope models category. We are going to cover different types. Example models of the scope model includes ecosystem map, event list, feature model, and context diagram. We have also the process models, models that describe the business processes and ways in which stakeholders interact with those processes. Examples include the process flow, use case, and user story, and we are covering all these different types as part of this lecture. Rule models, models of concepts and behaviors that define or constrain aspects of a business in order to enforce established business policies. Example models include the business rules catalog, the decision table, and the decision tree. We have also the data models, models that document the data used in a process or system and its life cycle. Examples include the data dictionary, the data flow diagram, entity relationship diagram, state diagram, and state table. And the last category is the interface models, models that assist in understanding specific systems and their relationships within a solution and with users. Examples of the interface models include the display action response model, prototype, report table, system interface table, user interface flow, and wire frames. All these are examples of interface models. So there are more than 17 or 18 models that I will be covering in this lecture. And in the PMI PBA exam, you should expect at least 1 or 2 questions about each of those different types of models. So what are the inputs you need? We need 3 inputs to kick off, create, and analyze models process, starting with the analysis approach, which is an output of the determine analysis approach process. It defines how to conduct the analysis. It includes a list of candidate models to be created as part of this process. As the models are analyzed, new model types might need to be created and the analysis approach may need to be updated. The analysis approach also describes the requirements architecture that describes which models are most likely to relate to one another for modeling elaboration. So this is the first input, and this is why you will need the analysis approach as an input for the create and analyze models process. Now you will also need the confirmed elicitation results, which is an output of conduct elicitation process. Confirmed elicitation results includes notes, requirements, and other outputs from completed elicitation activities. These results include the information that is needed to create first draft models. As the models are created and analyzed for gaps, the business analyst may discover additional questions about scope, processes, rules, data, or interfaces that will require additional elicitation. And the last input will be requirements and other product information. It's the subset of this information that is most relevant as an input in any previously defined requirements, acceptance criteria, and other analysis models. So these are the 3 inputs you need to have before you kick off creating and analyzing different models. Now, when it comes to the tools and techniques used in this process, we are going to cover 5 categories of the models you might create in this process. So you will find a navigator on the top left of this page. We will start with the scope models, and starting with the most popular scope model, which is the context diagram. So it is defined as a scope model that shows all the direct system and human interfaces to systems that are being built in the solution. So a context diagram clearly depicts the in-scope systems and any inputs or outputs, including the systems or actors providing or receiving them. So this is what you should expect once you create a context diagram. You can see the system, which is part of the solution, and all the interaction with the human interfaces and the direct systems. Context diagrams are generally created early in the project in order to define the scope and can be updated as new information is being uncovered or identified. They also help identify interface requirements and data requirements. So this is how a context diagram should look like. For any shape like this, it is the external entity interacting with the system, and for any circular shape, it's the system within a solution, and this is the data flow between the system and other users and systems. So the context diagram might be very helpful, especially at the early phases of the project, in order to define the scope. And it will be progressively elaborated and updated when new information is being identified. The second model I will be covering is a data model. It's the data dictionary. It's defined as the data model that lists the data fields and attributes of those fields for a data object. So again, it's a data model. It falls into the data models category, and it will list all the data fields and the attributes of those fields for a data object. The data fields are additional details for the data projects in an entity relationship diagram. The attributes specify information about the fields, including business rules enforced by the data. Now, data dictionaries are often created after other data models have first been used in order to identify the data objects and when those objects need more details specified. So as from the name of this model, it's a data dictionary, and usually we will not start by performing or by establishing a data dictionary model. We will perform other data models, and at the end we will have a data dictionary to cover all the data fields and the attributes of these fields. Data dictionaries can be pulled from existing systems as a register of all data in the system, and used as an input for system enhancements. They are typically created in conjunction with defining the requirements and acceptance criteria. This is an example. So simply a data dictionary or a data dictionary model is a table listing all the object names and all the attributes of these objects. The third model is the data flow diagram. It's also a data model, so it is used to describe the movement of data between external entities, data stores, and processes. So as from the name, it's a data flow diagram. It is used to represent the flow of data, the movement of data between different entities, including data stores, processes, and external entities. External entities can be actors or systems. Data flow diagrams show the data inputs and outputs of each process. Data flow diagrams are usually created during the analysis. Entity relationship diagrams, which we are going to cover later on, with the process flows and the ecosystem maps, these are three types of models, are usually created first to identify the data objects, processes, and systems to show in a data flow diagram. This is a potential question for the PMI PBA exam. So what is the best time to create the data flow diagram in your project? Usually once we have the entity relationship diagram, the process flow, and the ecosystem map. Here is an example of a data flow diagram showing the movement of data, the flow of data between different objects, including a data store, including the different processes, external entities, and the human resources. The fourth model is a rule model. It is called the decision tree, and another model is the decision table, but we are covering them together because they are very similar to each other. So both the decision tree and the decision table are rule models that show a series of decisions and the outcomes to which the decisions lead. Decision trees and tables are often used to model business rules. The two decision models are used in different ways and both might be needed. So one of them will represent the data as a tree and one of them will represent the data in a tabular format. And both are rule models usually used to model the business rules applied in the project. Decision trees visually show the flow of decisions and choices that lead to an outcome and can show ordered decisions, while decision tables are useful for ensuring that the business analyst has considered all possible combinations of decision scenarios and related outcomes. So this is the key difference between the decision tree and the decision table. Both decision models can be employed at any point to further analyze decision logic. Decision trees are usually easier for stakeholders to review because they will have a visual representation, a graphic, more than a decision table, which will have a tabular format. And both decision trees and decision tables are useful as a foundation for test case creation, with each combination of decisions and outcomes being a test case. Here is an example of a decision tree. So if you are familiar with the risk analysis, the decision tree analysis is one of the most popular techniques we will use while analyzing the project risks. Here is decision 1 with the expected outcomes, for example. So if you select decision 1, you will have choice B or choice C. And if you went with decision choice A, you will have another decision which will lead to outcomes 1 and 2. So it's a flow, starting with decision 1 that might be A or B or C, and then going to decision 2 which might be E or D. If you went, for example, for decision choice D, you will have the second outcome. This is why the decision tree is easier to read than a decision table. And here is an example of the decision table with the conditions that will be under the test case and the expected outcomes with the rules being applied. This is why it's a rule model. So this is the decision tree and the decision table. We have another popular scope model, which is the ecosystem map. It is defined as a scope model that shows all the relevant systems, the relationships between systems, and optionally any data objects passed between them. This model is very important for the PMI PBA exam. Expect like 2 or 3 questions about only the ecosystem map and another 2 or 3 questions about the context diagrams. So the systems shown in an ecosystem map are logically systems or business view. Therefore, they may not match physical systems, implementation view, and architectural diagrams. Ecosystem maps are most useful when they are created at the beginning of projects to understand all the systems that may be affected by or that will impact the in-scope systems. Ecosystem maps can be created for portfolios or programs to help identify potential dependencies between the projects. So you can notice that the majority of the scope models are very useful at the very early phases of the project in order to define the end scope of the project, like the ecosystem map and the context diagram. The ecosystem map allows the business analyst to see where there are possible interface requirements or data requirements for systems directly interfacing to the solution and for those up or downstream from the solution. So as you can see, this is the ecosystem map showing all the relevant systems in the ecosystem and the relationships between those systems, and sometimes, as shown in front of you, it will show the data objects passing between the different systems. So it will be very helpful model in defining the product scope. Another important data model is the entity relationship diagram, or the ERD. For my PMI PBA exam, I got 2 questions about the entity relationship diagram. Now, it's also called the business data diagram. It's defined as a data model that shows the business data objects or pieces of information of interest in a product and the cardinality relationship between those objects. So one of the questions in the PMI PBA exam was about the definition of the cardinality used in the entity relationship diagram, which I will explain now. Now, cardinality is defined as the number of times that one entity occurs in relationship to other entity and the relationship itself, and whether the relationship is required or optional. So when you are creating an entity relationship diagram, cardinality relationship between 2 objects shown on the model is the number of times that one entity occurs in a relationship to other entity in the same relationship, and whether this type of relationship is required or it's only optional. The data objects shown in an entity relationship diagram are not meant to be exact data objects in a database, but rather a conceptual view of the data in the solution from the perspective of the business. So this is the definition of the entity relationship diagram, a popular data model, and it helps usually identify the data that are created and consumed by or output from a system, and when used along with other process models, the ERDs can be used to model the data of importance from a process perspective. So the entity relationship diagram can be used alongside with the process models, and they are typically created relatively early in analysis in order to understand the scope of the data to be analyzed. This model also helps identify any processes that might create, consume, or manipulate the data, as well as the business rules about the data. ERDs are also a likely input for database designers and architects to use while they are designing the database of the product. An entity relationship diagram should look like this, and the numbers you are seeing here represents the cardinality, which we just explained, and simply an entity relationship diagram will show different business data objects and the cardinality between them. So if there is the number of 1, like in this case, it means that there is only 1 cardinality, and if there is 0 to n, none up to many cardinality relationships, 0 with 2 dots up to 1, none or single cardinality, and 1 to n means single up to many cardinality. This line represents the relationship between different business data objects. Another important scope model is the event list. So as from the name, it's a list or the table. It's defined as a scope model that describes any external events that trigger solution behavior. Event lists help define the in-scope events that the solution has to react or to handle. So in order to create this type of scope models, you need to have a list of all the in-scope events that the solution needs to react or handle. An event response table is a related model that extends the event list to describe the system's response to any events triggers. So we can have the event list scope model, and we can have also the event response table to align with the event list. Event lists are created early to ensure that the scope of the work is defined and might be updated as work continues and new events are identified. Event response tables are created to help identify the likely use cases, user stories, or system flows. Here is an example of the event response table. So in this model, we have 5 events that the solution has to react to or handle, the system state with each event, and what is the expected response to any of the event triggers. This is the event list, and again, because it is a scope model, it is preferred to be used at the early phases of the project. Tool or technique number 8 is another scope model, the feature model. It is a scope model that visually represents all the features of a solution arranged in a tree or hierarchical structure. For me, while conducting business analysis activities, this is one of the preferred models I usually create on my projects. It's very easy for the stakeholders to read and understand. So most projects have features at varying levels. The top level features are called level 1 or L1 features, followed by level 2 or L2 features, and so on. Feature models are helpful to show how features are grouped together and which features are sub-features of other ones. So it will show the connection between the different features of a product. Feature models are usually useful because they can easily display many features across different levels on a single page, which may represent the entire solution's feature list. This is why it's my preferable model to use, especially when you are explaining the features the product will cover at the end of the project for multiple number of stakeholders. This model is typically started at the beginning of a project because it's a scope model, and it will show all the features that are in scope for a program or a project, and it's updated progressively, elaborated as additional features or information is being identified during elicitation and analysis. In adaptive projects or projects managed using an agile approach, the features can be labeled for inclusion in different iterations to facilitate release planning. It means that because adaptive projects are based on various iterations and each group of features are expected to be implemented in one of those iterations, while creating a feature model in an adaptive project, we can label in which iteration we are expecting this feature to be built. The feature model can be used in combination with a brainstorming technique to help the stakeholders identify features by focusing on the grouping similar to an affinity diagram. Affinity diagram is based on grouping each group of features based on similarities. So here is an example of a feature model showing the features up to the 3rd level. So here is the product concept, L1 features, okay, and then we will go down to L2 features and then L3 features. So by looking at the feature model, you can see all the features that will be applied in the product or the solution being built in this project. So it's very useful to use when meeting with the stakeholders on the project. Technique or model number 9 is the goal model. The goal model and the business objective model. So there are two types of models, and both are scope models that organize and reflect the goals and business objectives in relation to other product information. Goal models typically show the stakeholder goals for a solution with any supporting or conflicting goal relationships indicated. So as from the name, it is used to organize and reflect the goals and the business objectives. The business objectives models relate the business problems, the objectives, and top-level features. Goal models and business objectives models are typically created at the start of a new program or project, or even earlier, to help prioritize programs and projects as part of a portfolio. So they can be created at any point for prioritization purposes. So scope models, the goal model and the business objective model, can be used as scope models, and they can be used also as prioritization tools and techniques. It can be used at the early phases of the project to define the scope and to align the scope with the business goals and objectives, or you can use in order to prioritize different projects and programs that are part of a portfolio. In business objectives models, business problems and business objectives decompose high-level business strategies into lower-level problems and business objectives to visually represent the value of the portfolio, program, or project, and how the solution will achieve the business objectives. Whether the value is identified as increasing revenue, decreasing cost, or avoiding penalties, all these are examples of values identified. Goal models and business objectives models visually represent the value that supports feature prioritization decisions and product scope management. Here is an example of the goal models and the business objective models showing the business problem, the business objective, and the flow till we reach the different features of the product concept. So it will show the relationship between the different features of the product and the business problems and objectives.